All right, last thing we're going to look at with derivatives is graphing them. In this problem, they want us to graph this, graph the velocity function of this um, graph that shows a position, because here we got meters and seconds, so they're showing the location at each time. Well, if you want to graph a derivative, it's the rate of change, and if we're looking at a graph, the rate of change is the slope. And so what we're going to be looking at when we want to graph this is we're going to try to graph the slope of the position graph to get the velocity graph. So on this first one here, from a time of 0 to a time of 1, there is a constant change here of going up 3 and over 1. And so the slope through that whole portion is 3. From 1 to 2 seconds, we can see that our graph never changes a position. And so if it's not moving, the velocity is going to be 0 in that spot. And another way of knowing that is what's the slope of that line right here? Well, it's horizontal. A horizontal line has a slope of 0. All right, continuing on now, the next part has a slope there that is decreasing. It's going down 2, right 1. That's a slope of -2. So on our graph down here, we need to actually extend this a little bit so that we can graph out -2. So from 2 seconds over to 3 seconds, it should be going across there. Now the negative with that doesn't, what that just indicates is a direction with velocity. So if your velocity is negative, it just indicates the direction that it's moving. All right, we got 2 little parts left, it looks like here. Again, it's not changing position from 3 to 4. So the velocity is 0 right there. Our last section, from 4 seconds to 6 seconds, looks like the slope of that line is up 1, right 1, so that's a velocity of 1 all the way through. And now that's a graph of our velocity in relation to time. So we got a velocity graph there. The last thing, and we'll get into this more later as we review derivatives, but at a corner, since the velocity is different here than it is here, the corners do not have derivatives. So really on our graph here, we should also be putting open circles to indicate that there are no derivatives at those end points since we have corners going on.